So I am going to take the question number 26. Two masses 2m m are attached to the ends of a string while passing over a smooth pulley. Mass m and radius r. The ratio of tension in the both string is. So this is very important point for us. A smooth pulley. If pulley is not smooth, I mean to say if friction is there, then tension for both sides will be different. But if there is no friction and pulley is smooth, then tension will remain same on both sides. So there is no confusion. The ratio between tension in both sides will be 1:1, because we can treat this question just like a smooth pulley and light string in the case of laws of motion. So there will be no change in tension. So we can say my option number 1 is correct. So if I go for question number 27, which of the following statement is correct? The first option is the normal reaction and the gravitational force on the body placed on a surface are action reaction. No, this is false, because in the case of normal force we will draw perpendicular to the point of contact, and normal force will created by the surface, but gravitational force is created by the earth. So first option will be false. And if I go for option number 2, the direction of friction force on a body placed on a rough surface is always opposite to the applied force. No, the direction of friction opposite to the relative motion, not in applied force. So this is also false statement. Because अगर हम लोग बहुत सारे एग्जाम्पल देखें कि ब्लॉक ऑन ब्लॉक प्रॉब्लम हम लोग सॉल्व करते हैं, तो इफ ये ब्लॉक जब मूव करेगा तो दिस ब्लॉक विल एक्सपीरियंस ए सीडो फोर्स एंड दिस ब्लॉक ट्राई टू डिस्प्लेस ओवर द बिगर ब्लॉक, देन m1 and m2 will take a relative motion. So during this activity, m1 and m2 will take relative motion with each other. So friction force will be created on this side. So we are saying that the motion of this system is from left to right, and friction force is also left to right, and the direction of external force is also left to right. So इस केस में हम बोल सकते हैं कि direction of friction and direction of external force both are in same direction. So on behalf of that we can say option number 2 is not correct. This is a wrong statement, but I need a correct. So we'll go for option number 3. The normal force on a body placed on a rough surface is always equal to weight of the body. No, this is not possible in all cases. So third option will not be correct. And if I go for option number 4, a body in motion may not be acted upon by the force. Yes, this is possible. If body is moving with constant velocity, then there is no acceleration, so no force, but body can take a motion. So if I repeat that, a body in motion may not be acted upon by a force. Yes, this is possible. So my option number 4 is correct. If I go for question number 28, a thin rod of mass m, length L is released from rest in the position shown. The path of center of mass of rod till the rod becomes horizontal, assume surface is smooth. So we'll see, there is a force, weight will act in downward direction, and there is another force, that is normal force. So when a rod will move, so just like this is the initial position and this is the another situation. So in this way, suppose initial position of the center of mass is here, the center of mass will move from position 1 up to 2 is here. So when rod will becomes horizontal, then center of mass will move downward. So we are saying that the path of the center of mass is a straight line, because there are only two forces, one is weight, another is normal. So my option number 2 is correct. So if I go in the question number 29, we'll see a uniform rod of mass m, length L, kept on a horizontal table with L by 4, length on the table as shown in the figure, as the ring attached to the end B is cut, the angular acceleration of the rod about point C. So I need to calculate the torque about point C, because question I need to calculate, according to the problem, angular acceleration of the rod about point C will be. So if I go for the free body diagram for the calculation of torque, so this is, and this is the my point C. So if I draw a normal force and this is the position of center of mass, so mg will act in downward direction. When point B string is cut, then rod will rotate. So if I go for the torque about point C, so that is equal to mg into perpendicular distance. So perpendicular distance as per the problem is L by 4, because this is the line of action for the mg, but I need to calculate torque about C, so this is L by 4, and we know that this torque is equal to I alpha. So I alpha is equal to mg L by 4, and now I need the moment of inertia about point C. And I would like to explain one thing. If I go for torque regarding normal force, so normal force will pass through the point of C, so there is no perpendicular distance. That's why we are not going to take torque about the normal with respect to the point C. And now if I go for the moment of inertia I with respect to the C, and the another axis will pass through the center of mass of the rod, and I need to calculate moment of inertia about an axis which is passing through the point C, so we can use the parallel axis theorem. So we'll write ICM, moment of inertia about geometrical axis, plus md square. D is the perpendicular distance between these two parallel axes. This is the D, and that is equal to mg L by 4. So now I am going to place the value. ICM of the rod is 1 upon 12 ml square, plus mass D is equal to L by 4, so L upon 4 square, and alpha is also there, so into alpha, that is equal to mg L by 4, and this is my final equation. So if I go for the calculation with the help of this equation, on solving we'll get alpha is equal to 12g upon 7l. जब हम लोग सॉल्व करेंगे इस इक्वेशन को, मास को कॉमन लेंगे, एल को कॉमन लेंगे, कैंसिल हो जाएगा, एंड व्हेन यू विल कैलकुलेट अल्फा यू विल गेट दिस 12g by 7l. So my option number 2 is correct. Let's move on question number 30. So now I am going to take the question number 30. A particle is projected with initial velocity u at an angle theta with the horizontal. The variation of angular momentum L about starting point with respect to the time t will be. So if I concentrate the force on this particle, this is only mg, and if I consider the displacement along x-axis is x, and if I calculate at random at any point the torque with respect to the starting point, then torque will be calculated by force into perpendicular distance, and perpendicular distance is x, because this is the line of action. Okay, so now if I want to calculate x, x is given by v into t. V is the velocity at this point as I consider, So torque is equal to mg into v into t. But we know that torque is calculated by the change in angular momentum with respect to the time. So we'll write dl tau into dt. So if I go for the angular momentum, we will take the integration, and first I will place the value of torque, that is mg vt, and if I go for integration, so we'll get mg v t square by 2, and this is equal to angular momentum mgv t square by 2. So you know that weight mg will remain constant, velocity v t square. So if I concentrate about only the relation between angular momentum with respect to the time, so L is directly proportional to t square. So this is the graph just like y is equal to x square. So on behalf of that, we can say my option number 2 is correct. So let's move on question number 31.